Hello, hello, hello. So today's question is here. It is the question of 2014, October, November, paper 1-1, and of course physics. It is 9702, and the question number is 16. So it says that a projectile is fired at 45 degree to the horizontal. So that means it is fired somewhat like this. So we fire it like this, and the angle it makes with the horizontal in the very beginning is 45 degree. It has got initial KE is E, so that means the KE initial is equal to simply E. Now assuming negligible air resistance, that means we are not considering the air resistance, what will be its kinetic energy when it reaches the highest point? So here we have to find the KE at the highest point. So let me write it as KE final. So before doing that, let us go through the velocity, because the kinetic energy is equal to half of mass into velocity square. So if I consider here, in the beginning, let its velocity be u, initial velocity u. So at that time, the horizontal velocity, which we often call as the component, this velocity will be equal to UH is equal to u cos of theta. And the vertical velocity at that time, initial, we often call it as vertical component, its value is equal to uv equal to u sine of theta. As it goes upward, this component will decrease, and this component should remain constant. It should remain constant because there is no horizontal force. So the horizontal velocity should be constant. Since there is no horizontal force, the horizontal velocity should be constant. So this thing remains constant, but this thing, it decreases because there is a vertical force on the projectile wherever it goes. So this thing is exactly opposite to this. So this must decrease. So at the very top, from our previous knowledge, what we can say is, at the very top, the horizontal velocity is still there, and its value is equal to this. So here, this velocity VH is equal to simply UH. VH equal to UH. But since it is traveling horizontally at that time, at the highest point it travels horizontally. So that's why the vertical velocity here is V vertical equal to 0. V vertical is equal to 0 here. So that means the velocity is composed of only the horizontal part. So let's see here. The kinetic energy here is the initial KE. The initial KE initial is equal to, it is 1 by 2 mu square. Mu square. Now the KE here is, the KE final is equal to 1 by 2 m into V square. Let us write. Now this V square is composed of two things. It's equal to 1 by 2 m. It is V horizontal square plus V vertical square. Because V is the resultant of the horizontal and the vertical. And that's equal to 1 by 2 m. V horizontal is, it is simply UH square. So it is UH square plus it is 0. And that's equal to 1 by 2 m UH square. Again, what we have done is UH equal to U cos theta. So this thing becomes equal to 1 by 2 m U square cos square theta, and that will be equal to, so if you write it as E, what is given here is the initial KE is equal to E. So that's why if this is E, this term should be E. So it's equal to E cos square theta. Now let us use this value theta. Theta is equal to 45 degree. So this will give us E cos square 45 degree. That's equal to E into 1 by root 2 square, and that's equal to E into 1 by 2, which will ultimately give the value as this KE final is equal to 0.50 into E. So this means the KE at the highest point is half of the KE at the initial point. So we have choice number A is the correct answer. And in a similar manner, we can find the KE at various heights. So let us say we can find the KE over here, we can find KE over here, and we can even find KE over here. And here, the value of KE at the landing point, the value of KE will be definitely equal to the value of KE here, because the firing velocity here and the landing velocity here will ultimately equal in magnitude. So the KE should also be equal. So this approach will help us in finding the KE at every possible points.